The health risk posed by welding fume is serious. However, keeping yourself safe can be straightforward. When it comes to welding fume, all efforts should be made to mitigate the risks where possible through elimination and substitution of risk. Welding fume monitoring is the first step in this process. An occupational hygienist can sample your workplace atmospheres to determine whether welders and workers in the vicinity of welding fume sources are exposed to significant levels of hazardous chemicals. Results from welding fume monitoring can indicate how effectively your existing control measures are performing and whether any changes are required. A report is then normally provided that will present control methods to mitigate welding fume exposure. Examples include removing surface coatings on materials, changing to less hazardous materials, both for consumables and base materials, using a welding technique that produces less fume, a different application, or working with lower amps, for example. Whilst the highest level of controls, elimination and substitution, within the hierarchy of control, give the highest level of control and reliability in many industries, they are often not practicable or possible when it comes to the welding industry. Substituting materials can result in quality issues, and using lower amps is often not an option. Even when you can mitigate risk, if there is welding to be done, there will be some amount of welding fume. Welding fume is inherent in the process of welding. As a result, we see that in the welding industry, the higher levels of control can often only mitigate the risks associated with welding fume, making the lower levels of control, such as product controls, essential parts of the control strategy. In relation to the hierarchy of controls, PPE is often referred to as the last resort. When it comes to welding, suitable PPE must always be worn. Respiratory protective equipment, RPE, for protection against welding fume is commonly available in two main forms: welding helmets with integrated respiratory protection and half-mask respirators. Disposable or reusable half-mask respirators can be worn underneath a welding helmet to provide a required minimum protection factor, RMPF, of 10 as per AS NZS 1715, meaning the air that passes through the respirator will be at least 10 times cleaner than the air you would breathe if you were unprotected. The welder must be fit tested on the specific mask and clean shaven daily to ensure an effective negative pressure seal to achieve this RMPF. Welding helmets with integrated powered air purifying respirators are the most widely used form of respiratory protection amongst welders in Australia and New Zealand and are mandatory within many businesses. They have a required minimum protection factor, RMPF, of 50, offering 5 times the level of respiratory protection of a half-mask respirator. PAPRs can provide protection to welders using the most common materials and applications. A PAPR also has a number of comfort advantages over half-mask respirators, which is an important safety aspect. The more comfortable a piece of PPE is to wear, the more likely it will be worn correctly. As a half-mask respirator becomes increasingly loaded with fume, it becomes harder to breathe through. They can also become hot and sweaty, interfere with the welding helmet, and can give a claustrophobic feel being worn, pulled firmly onto the face. Conversely, a PAPR offers a steady flow of fresh air which can cool and ventilate and add to the welder's comfort level. When a welder is using a welding helmet with a half-mask respirator, they will often lift the helmet when they have finished welding, leaving themselves vulnerable to radiation and high-velocity hazards generated by other workers. The respirator protects the welder from respiratory hazards, but the welder no longer has eye or face protection in place. With a flip-up welding helmet with powered air respiratory protection, welders can have completely clear and uninhibited views of their workpiece and surroundings while maintaining their desired level of respiratory protection with constant eye and face protection. A recent study conducted within a large manufacturing company with over 1,500 employees, including 600 certified welders, found that foreign body eye injuries decreased over 70% year on year in areas that implemented the PAPRs with integrated flip-up auto-darkening welding helmets. Worker compensation claims decreased markedly while employee morale increased substantially. From a cost perspective, long-term, a PAPR can be the more economical option. A PAPR draws air into the system from behind the welder, away from the greatest concentration of welding fume. For this reason, the filters on a PAPR will typically need to be changed less frequently than a disposable respirator or reusable respiratory filters. While half-mask respirators have a lower upfront cost, they can be the more expensive long-term option. Worn on the welder's face in closer proximity to the plume, filters can become loaded extremely quickly in certain welding environments, meaning regular replacement and significant cost. Procedural controls must also be introduced to support mitigation of risk and product-based respiratory controls. As an employer, once you have selected the appropriate PPE, you must provide the worker with information, training and instruction in the proper use and wearing of that PPE. Proper guidance should be given on the storage of equipment, and care and maintenance guidelines should be clear and followed. The Speedglas Powered Air Training Academy, SPATR, has been launched to provide workplaces with a set of training modules to educate and train staff in line with the suggested syllabus set out in the Australian and New Zealand Standard 1715, Section 7, for workers using respiratory protective equipment. Ensure you select suppliers who can not only provide equipment, but also administer the required training and support. Also, ensure all required spare parts are readily available and stocked. Administrative controls also extend to working area considerations, including, but not limited to, minimising work conducted in restricted or confined spaces, introducing a dedicated area for welding, and controlling access to this area. The hazards of welding fume also extend to non-welders. When you consider a very small welding fume particle can potentially take 2 days to reach the floor when released from a height of 1.5 metres, you begin to understand how long these particles, some carcinogenic, can remain suspended in the workplace breathing air. This effect is vital to consider when welders are sharing the same environment as non-welders, as the air can contain respiratory hazards long after welding has been completed. Clear visors with powered air can provide protection from welding fume, as well as high-impact eye and face protection, and optional hearing and head protection for non-welders. Well-designed and located extract ventilation is another option that can be introduced to effectively remove welding fume from reaching the wider working environment. Air monitoring should take place if you are at any time unsure about the level of welding fume exposure to workers, or to test the effectiveness of your current fume control framework. For more information, please contact AWS.